Good morning, ma'am. My name is Indevi. I am from ECE. Today I am going to tell you about maxima and minima of functions of two variables, and the working rule of this maxima and minima of functions of two variables is: first we find dou u by dou x and dou u by dou y and equate each to 0. Solve these equations for x and y and we get the point of values. Then we can find the values of L, M and N for each pair of values obtained. We can find the L value by using dou square u by dou x square, and M value dou square u by dou x into dou y, and N value we get from dou square u by dou y square for each pair of values obtained. If ln minus m square greater than 0 and L less than 0, then we get a point of maximum. If ln minus m square greater than 0 and L less than 0, then a point of maximum. If ln minus m square greater than 0 and L greater than 0, then we get a point of minimum. If ln minus m square less than 0, then there is neither a maximum nor minimum point. If ln minus m square is equals to 0, there is no conclusion can be drawn about maximum or minimum, and we can need further investigation. Here we take a simple problem to find the maximum and minimum values of two variables, and the given question is: examine for minimum and maximum values of sin x plus sin y plus sin of x plus y. First we can write the given values. Given, we consider it as u of x comma y is equal to sin x plus sin y plus sin of x plus y. U of x comma y is equals to sin x plus sin y plus sin of x plus y. It is considered as equation 1, and then equation 1 differentiate with respect to x. We get dou u by dou x is equals to cos x plus cos of x plus y, when we know that as differentiate with sin x, as we get cos x. Equation 1, again equation 1 differentiate with respect to y, and dou u by dou y is equals to cos y plus cos of x plus y, and we subtract the equation 2 with equation 3, and equation 2 is cos x plus cos of x plus y, and we subtracting the third equation minus cos y minus cos of x plus y is equals to 0. Cos x minus cos, and we cancel the cos of x plus y and minus cos of x plus y, we get the cos x minus cos y is equals to 0. Cos x is equals to cos y, then we get the x is equals to y. If we substitute the value of x is equals to y in equation 2, we get cos y plus cos of y plus y is equals to 0. Then cos y is plus cos 2y is equals to 0, as we note that the formula of cos c plus cos d is equals to 2 cos c plus d by 2 cos of c minus d by 2, and 2 cos of y plus 2y by 2 and cos of y minus 2y by 2 is equals to 0. When we solve this, we can get 2 cos 3y by 2 cos of minus y by 2. If we consider as it two parts, then we can get 2 cos of 3y by 2 is equals to 0, and we know that the value of cos 0 is pi by 2, but we don't know it is positive or negative, so we can write it as plus or minus pi by 2. So we get 3y is equals to plus or minus pi, and y is equals to plus or minus pi by 3. If we consider another part of this problem is cos y by 2 is equals to 0 and y by 2 is equals to plus or minus pi by 2. How the pi by 2 is cos 0 is nothing but plus pi by 2, but we don't know it is positive or negative, so we can write plus or minus, and solving this we can get y is equals to plus or minus pi. and by taking y is equals to x, we get the same values. So y is equals to plus or minus pi by 3 and x is equals to plus or minus pi by 3. We can write it as a points is equals to x comma y is equals to plus or minus pi by 3 comma plus or minus pi by 3. And the second point is y is equals to plus or minus pi and x is equal to plus or minus pi. If we write it as a points, y is equals to x comma y is equals to plus or minus pi comma plus or minus pi. Again differentiate equation 2 with respect to x. Dou square u by dou x square is equals to minus sin x minus sin of x plus y. As we know that when we differentiate cos x, we get negative sin x, and this dou square u by dou x square is the value of L. So the value of L is equals to minus sin x minus sin of x plus y. And we want to another two values, nothing but m comma n. Again differentiate equation 2 with respect to y. Dou square u by dou x into dou y is equals to minus sin of x plus y, and the value of nothing but m value, and m value is nothing but minus sin of x plus y. Differentiate equation 3 with respect to y. Dou square u by dou y square is equals to minus sin y minus sin of x plus y. N is equals to minus sin y and minus sin of x plus y. As we know that n is equals to dou square u by dou y square. At a point of pi by 3 comma pi by 3, the value of L we get L is equals to minus pi by 3 by solving all the L value, and we get m value is minus root 3 by 2, and we from this first we know that ln minus m square value, and by solving these we can get ln minus m square is 9 by 4 and it is greater than 0. So u has a maximum at pi by 3 comma pi by 3. As if we consider plus pi by 3 comma pi by 3, but we don't know minus pi by 3 comma minus pi by 3 values. If we solve ln m and values, we can get L is equals to root 3, m is equals to root 3 by 2, and here L and n are same. So ln minus m square is equals to we get 9 by 4 greater than 0, but here L is not 0. Here L is greater than 0. So and ln minus m square is greater than 0 and L greater than 0. So u has minimum at minus pi by 3 comma pi by 3. At pi comma pi, we can get the values like L is equals to 0, m is equals to 0, and we substitute all these values in ln minus m square is equals to 0. Finally we get the ln minus m square is equals to 0. For this there is no conclusion can be drawn about maxima and minima, and we can get through further investigation. Thank you, ma'am.